Hello guys, welcome to this basic power system series. Okay, so in this series we have already covered all the 12th topic. This is our last. Uh, we have already covered 11 topic. This is our last and 12th topic. HVDC termination system line. Okay, if you have come here for the first time, I would like to request you to subscribe this channel. Okay, so let's start this topic. We are just covering basic things of power system. Okay. So our topic is HVDC or high voltage DC transmissions. As you can see this figure, this is one figure of overhead HVDC transmissions line. Okay, so when transporting large amount of power over long distance or over long distance or underwater, it can be transmitted also. And HVDC transmission is used because it is more economical than AC transmissions. Okay, for overhead as well as for cable underwater, we used DC HV high voltage DC transmissions line compare because it is more economical compared to AC transmission. That's why we don't use AC transmissions line for long distance. Whenever it is long distance, okay. So this require more facilities in the transmissions and interconnection system, which can be costly. Therefore, choosing between AC and DC transmission is crucial for ensuring greater reliability. HVDC transmission is the most efficient and economical options for power transmissions. Okay. Uh, AC is also good, but for long distance, it is not good. Okay, there are different problems are there. AC transmissions line face different types of problem. Okay, so what is HVDC or what is high voltage DC? So as you can see in the figure, from the thermal or wind only it's showing, or we can say from the main grid or microgrid or from the generation stations, power is transmitted through the transmission line by at first it converted to AC to DC. Okay, by then through this transmission line, this is DC line. That's why we are converting it. Okay. Then again, when we are about to supply to consumers, then again we are using converter DC to AC, and this is the transmission line for using for long distance. Whenever we need to transfer power for long distance. Okay. So what is HVDC? Let's read it. Electric power is generated, transmitted, and distributed. The main thing is there. Here, generated, transmitted, and this is distribution line connected to the consumer, directly supplying to consumer. Okay. So from generating stations, power is delivered to end user. End user means consumer. Okay. Through transmissions and distributions line, the transmissions line and distributions line. These are the distributions line. Okay, which are long and operate at high or extra high voltage. This transmissions line normally operate at high voltage. Okay. However, the amount of AC power transmitted is limited by lines inductance. Okay. AC power, when AC power transmitted is limited by the line inductance. There are like it face problem due to inductance. Okay, impedance. To overcome these limitations, one problem that is skin effect due to impedance it AC line. If you don't know AC skin effect, I have made videos on skin effect. You can check those other videos. Okay, what is skin effect and all. To overcome these limitations, high voltage DC transmission lines is typically used for high power transmissions. Okay, both we can use both AC and DC. Both we can use, but for long distance, keep it in mind that for long distance we use DC, and that is we transfer when it is long distance. We transfer level up the power. Okay, voltage to high voltage. That's why it is high voltage HVDC. AC also we can supply, but AC it face different different types of problem. Uh, DC also face different types of problem, but compared to if we both compare AC and DC, DC for it came better for long distance transmissions. Okay, that's why we choose HVDC high voltage because we are convert stepping up. Okay, by using transformer also. I have not shown here. Okay, in this figure. So at the end of the DC power system, the DC power is converted back to AC. Okay, here this thing we were saying at the end we are converting it again to AC. The entire HVDC transmission consists of three main sections: converter systems, transmission sections. Converter section is this converter and this converter both. Okay, and transmission section is this one. Transmission sections. Okay, contact transmissions line and tower, and then inverter sections. Okay, converter sections and inverter sections. Okay, the sending end or converter station is sending end. This is sending end. Power we are sending from there to there. Okay, is this a 6, 12, or 24 pulse thyristor? Thyristor not showing in the figure. Okay, bridge rectifier, while the receiving end or inverter station uses similar configured thyristor bridge that operates in inverter mode. Okay, here we use it here. So HBTC has advantages. We are not going that much details. Okay, we are just covering basic parts. In advanced power system series, we'll be covering all details, whatever we can. So advantages of high voltage DC over DC transmission systems are: for a single line in DC transmissions, so many theories are added here. Okay, because its point is like that. In the advantages, we have not discussed with some figures or calculations or something. We're just giving one para point wise. Okay, for a single line in DC transmission, just two conductors are required. If you just read once, it is not that much complex things. Okay, for a single line in DC transmissions, just two conductors are required. DC for DC only two. Okay, phase and neutral with earth written. That neutral one is earth written. One conductor is sufficient. With two conductors with earth written, the line's capacity is doubled. However, a minimum of three conductors are required for AC. If we transfer through AC, that then we at minimum we need three conductors. Okay, and a double circuit line will require six conductors. Okay, double circuit if there is then six into two. So compared to losses in AC transmission, it can carry electricity effectively across large distance with fewer transmissions loss. Also, I square R loss also less in DC. Okay, maintaining synchronization between two AC system is no longer necessary when there is a DC link between them. Okay, there is DC link is there. DC link capacitor. It's a little bit advanced thing. Okay, let's just ignore it. So on the okay, let's go to next point. In a HVDC system, high-speed power flow regulations is simple and straightforward. The power flow across the link is determined by the converter station's automatic controller. Okay, since no reactive power is required for transmissions for DC, so there is no stability issues resulting from the length of the transmissions line. But if we talk about AC, obviously there is reactive power. Okay, real power and reactive power in AC. The quick and efficient regulations of the HVDC link allow for the dynamic achievement of fault isolation between the transmitting and receiving ends. Okay, for economic reasons, also it is required to restrict the potential switching transient in HV AC transmissions for voltages higher than 400 kilovolts. When HVDC is used, these issues don't arise. Okay, switching transients you need for AC. So it has some disadvantages also. Okay, if you just read this topic, what you have to do. These are points like that. Yeah. So disadvantages also, it has some disadvantages. DC, it means the HVDC. So let's talk about this. The systems are costly. Okay, these systems are costly. Installations are complicated due to converter. We are not comparing here totally AC with AC. Okay, installations are complicated due to converter. The converter are there because at end sending end as well as at receiving end also converter needed. At first AC to DC, then DC to AC we are converting. Okay, so DC switch here is expensive and filters are regulated. Filters are regulated because harmonics are generated. Okay, in this DC line, and that harmonic is if we don't use filter, it will be transferred to AC line also. Okay, then it will affect the equipments, whatever equipments connected in AC at our home, at consumers, whatever they are using. Okay, converter do not have overload capacity. Okay, lack of HVDC circuit breaker. There is no device, DC device, which can perform excellent switching. Okay, circuit devices can be here, but showing excellent switching operations. In AC, it has like proper switching devices. Okay, and no DC transformer. Obviously, DC. This is one of the big problem. There is no DC transformer. All the transformer are AC. Okay, so we are just will go through the some basic points only. Okay, here we are going through theory only. Okay, later on maybe after completing this series, maybe we'll come with some uh, numerical problems. Okay, or basic processing. We'll see that one. Components of the HVDC transmission are this one is one HVDC transmission system. We can see here. Okay, so 612 or 24 pulse converters are connected. Converter is a converter transformer with an appropriate ratio and tap changing filters on both the DC and AC side. We need AC filter. Okay, AC side here filters, DC filters. Okay. Filters, what it is, we'll see little bit. What is it is? DC line. This is the transmissions line actually. Okay, this is the transmissions line. Another that's this is the receiving end part, and this is the sending end part. Okay, shunt capacitor, AC filter, converter, transformer, AC filter, AC bus, smoothing reactor. All these are components of the HVDC transmission systems. Okay, control systems. Okay, control system need for both. For everything, control system is needed. So converter unit, HVDC transmissions require a converter at each end of the line. Okay, starting and ending both ends, sending end and receiving end both need. This unit usually consists of two three-phase converter which are connected in series. Okay, that same thing we are talking about. And then due to evaluations of power related devices, the thyristor valves have been replaced by high power handling device such as gate turn of thyristors. These are some recent thyristors. Okay, IGBTs and light triggering thyristor. If you design any transmissions, any system, microgrid, solar, that time you'll see IGBTs are there. Okay, and grid connected. If you model something grid connected, you'll see those things. Okay, those are little bit like advanced thing. If you want to cover those, so filters. So filters are due to repetitive firing of thyristors because we are using thyristors. Okay, thyristors we are using IGBT and all. those things are we are using. Because of those, they are the continuously fire. Okay, firing means how to see here. It's they inject like that. So harmonics are generated in the HVDC systems. Harmonics also you can say normally if you want if there is one simple graph, maybe there will be spike. Okay, I'm not able to draw that. This is not proper. Maybe it's okay. You just for now let's just go with that. Harmonics are generated means some disturbance. Okay, in a simple graph. Okay, you can assume that. Harmonics are generated in HVDC systems. So these harmonics are converted to AC network if we don't use filter. That thing we already says. So in order to reduce harmonics, filters and filtering techniques are used. And types of filters include AC filters, DC filters, and high frequency filters. Okay. AC filters, these are made with passive components. They provide low impedance and shunt path for AC harmonic currents. Tuned as well as depth filter arrangement are generally used in this HVDC system. Best thing is if you take screenshot of these slides, or you can contact me through my email ID. I'll share my email ID after finishing at the end of this lecture. And if you want these slides, you can keep it as note. Okay, because we are just only covering theoretical parts. Okay, there are DC filters also similar to AC filter. These are also used for filtering the harmonics. Filters use a DC end. Okay, first are AC end at okay, and then high frequency filter. These are provided to suppress the high frequency currents. Okay, when there is high frequency currents, they suppress those things. Okay, in filters actually normally we use capacitor and inductor. Okay, those are mainly these two are mainly two components of filter. Okay, so shunt capacitor or reactive compensations and smoothing reactor, these are also the components of HVDC. Shunt, due to the delay in the firing angle of the converter stations, reactive volt amperes are generated in the process of conversion since the DC at the conversions. Okay, converter sections. Since the DC system does not require or generate any reactive per DC, that means no reactive, this must be suitably compensated. Okay, by using shunt capacitor connecting at both end of the system. At the converter, there is we are converting AC to DC and DC to AC. So AC is coming. Okay, that means there will be reactive power, but at the middle point there is DC transition line. So there is no reactive power. Okay, that reactive power. Okay, so that reactive power at the sending end at the receiving end, because of the converters to suppress compress that, we are using shunt capacitor. Okay, for reactive compensation. Smoothing reactor, it is a large series reactor which is used on DC side to smooth the DC current. Okay, as well as for protection purpose also. It regulates the DC current to a fixed value by opposing certain change in the input current from the converter. Okay. Transmission medium or transmissions lines or cable. Okay, what a transmission like this or DC transmissions line. Okay, we have discussed everything. DC and AC switch gears are there. Okay, these are the components of HVDC. Okay, the switchgear equipment provides the protections to the entire HVDC. Sorry, entire HVDC systems from various electrical faults, and also gives the metering indications. Okay, so types of HVDC system. There are three types of HVDC system. We'll just see the figure little bit. Okay, Monopolar links. Okay, monopolar link, very simple from the figure you can see. It is in this DC system, sending and receiving end converter are connected by a single connector. Okay, sending and receiving. This is the suppose sending end suppose, and this suppose we are saying receiving end. Only one conductor is connected. This both ends are connected through only one connector. That is monopolar link. Okay. Then bipolar. In bipolar, suppose this is sending end, sending end. This is suppose receiving end. Okay. So both these are connected through two connections. Okay. Here is one connection, another one connection. Okay, suppose one connection it became fault conditions occur here. The other connections will allow the flow of power. Okay. Then homopolar link. Let's only one earthing is here. Okay. Let's read it. This link has two or more conductors with the same polarity. Okay. Usually of negative, and they are operating with ground written. This one. If fault take place in one conductor, the converter equipment can be connected to healthy pole and it can supply more than 50% of rated power. Okay. By overloading at the expense of increased line load. This is not possible in case of bipolar link where guarded insulation is used for negative and positive poles. This system is preferred when continuous ground current are readable. The advantage of the system only difference is this things. Okay. Okay, we are not reading all the things. You can take screenshots if you want details video on these topics. You can comment in the comment video. Later on, I'll try to upload videos, details video on those topics. Okay. We are trying to make the video not smaller. We are trying to make it smaller, not lengthier. Okay. So applications of HVDC transmission systems, applications main thing is to transfer power. So long distance bulk power transmissions, this is the main thing. Okay. Long distance bulk power transmissions. Bulk power transmissions through underground or underwater cables also can be done. Interconnections of individually controlled AC systems can be done. Stabilization of power flow in interconnected power system. AC and DC lines in parallel. Frequency combustion. DC transmissions with AC distributions. This first and second, these are the main thing actually. So if you have any doubts, please comment in the comment box. And if you want details videos on different topics of suppose monopolar, bipolar, like that circuits, okay, transitions. So you can comment in the comment box. I'll surely upload videos as if you demand. And my humble request to everyone, please just plant only one tree. I think the only way to fight against global warming is to plant tree. If you plant only one tree in each Sunday or in a week, that is my request to you. Okay, I'm doing also same. I'm requesting you to do same also. And if you want the PPT, it is available. So okay, you can contact me through this mail. So we have already covered all the topics here. Okay, all the topics are covered. We are going simple basic things.